Reservations in two-way slabs by means of yield lines. This video deals with cases 21 to 25 with a slab which is a fixed end on all the four sides. And we'll deal now with case 22, which is a corner square hole or a corner hole on the top left. You got here the rectangular slab with the yield lines drawn by the 30, 45, 60 rule. And we have a reservation of D1 size D1 times D2. Two-way slab, so D is between alpha and 2 alpha. It's in the corner. It means that D2 is following this yield line, so D2 is equal to D1 times S1 over S4. Top left corner means that D4 and D3 is 0. And it's only cutting one yield line, so this reservation stops here at the end. So it means that D1, this one, D1 must be between 0 and S4. So these are the conditions. Because we have a 45-degree angle of the yield lines, D2 is equal to D1, and you have a square reservation in the slab. To visualize the process, the dark black line is the fixed end support, and the yellow one is the reservation. You will see that this reservation makes this movement, goes from there to there, and this is the largest possible one, and then the small one. The work done by the external forces can now be calculated. Let's take the orange area, which is composed out of a rectangular. So you have this side, which is B minus S1 minus S3 times A, and the mean deflection is delta over 2, which gives you this. And then the green elements, we got A times S1 plus A times S3, but we will subtract this part where the reservation is. So we have to subtract first this triangle, which means D1 times D2 divided by 2, and the maximum deflection is D1 over S4. D1 over S4. And for this triangle, the maximum deflection is D2 over S. Over S1, D2 over S1. So that's why you have those two subtractions from those two triangles. And the mean deflection of a triangle is delta over 3. You can fill in the values and you have this formula. The work done by the internal forces is the negative yield line on this side, which is B minus D2, and over the angle delta divided by S4. And we got this twice, 2 times, there and there. Then we've got the right here, we have this yield line projected on this axis of rotation, which is B divided by S2. And we have also this yield line, which is B times divided by S2. And on the other side, we have A divided by S3. And this is also A divided by S3. And on this side, we will have A minus, of course, D1, and the angle of rotation is delta divided by S1. And we got this 2 times. You fill in the different values, and then we can calculate the bending moment, and we use the dimensionless parameters by saying that B over A is alpha and D1 over A is alpha 1. So we have this nice formula for the maximum bending moment. Let's give an example now of a square slab 5 by 5 meters with a reservation in it of 1.5 times 1.5. The slab is 16 centimeters, concrete covered 30 millimeters, floor finish 2, and the mobile load is 10. What is the reinforcement for this slab? Well, the load in ultimate limit state is 1.35 times the permanent load plus 1.5 times the mobile load gives you 23.1 kilonewton per square meter. We have the different parameters. We make it dimensionless, so it's d1 over a. Alpha 1 is then 0.3 and alpha is 1. The maximum bending moment with the formula of the previous slides can easily be calculated, and it's 13.4 kilonewton meter per meter. Then we convert this into reinforcement. We take a lever arm in X direction and in Y direction, and then we take the mean lever arm, which is 122 millimeters. And the needed reinforcement is then 1.1 times the maximum bending moment divided by the lever arm divided by the yield strength. And we have 209 square millimeter per meter. This is okay for a diameter 8 every 150 millimeters. We will now look into another example, which is an existing slab, 5 by 5 meters. And we want to know if it's okay to make a reservation in the slab of 1 by 1 meter. We do not know what reinforcement is in the slab. We do not know the original load that the slab was calculated for. So, but we know that the top and bottom reinforcement are equal. So the maximum bending moment without the hole, M0, divided by the loads, because we don't know the load. So we take it on the left-hand side of the equation. And on the right-hand side is only a function of the geometry. So we can calculate that. It's 0.521. Then we look at the bending moment, the maximum bending moment with the hole, which is, and we divide also by the ultimate limit load. And we have a value of 0.569. So this means that the bearing capacity, 92%. So by making this reservation, we will decrease the load by 8%. So there's 8% loss in bearing capacity. So you should not make this reservation without other measurements. So bearing capacity is defined at 100 times the maximum bending moment without the hole divided by the maximum bending moment with the hole. It's in a formula, and we work with units without a dimension. So we know that for case 22 type of holes that we have those two restrictions, and then you can easily calculate the formula for the bearing capacity, which gives you this nice formula. And you can put it into a graph to learn something about it. On the x-axis, it's alpha 1, so it's the size of the reservation, and on the y-axis, it's the bearing capacity, and we do that for a slab, square slab, and we have alpha 1, alpha 1.5, and alpha 2. And you see that all slabs are between the red curve and the black curve. But still, every value is below 100%. So type case 22 reservation is always bad for the bearing capacity of the slab. The maximum loss is with a square, and this maximum is about 10% loss for alpha 1.3. So it means that if your reservation is bigger than alpha 1, it's better in bearing capacity. If it's smaller, it's also better. So to visualize it, it's something like that. Then for the blue dotted line, we got the maximum of 90.4. It looks like this. And for the black curve, the maximum is situated there, and it looks more or less like this. So those type of reservations give you the maximum loss of bearing capacity. So a hole type 22 that means following the yield lines in the left top corner of a rectangular concrete slab, leads to a loss of bearing capacity of maximum 10%. From there to there. That's the type 22 reservation.